Hello, everyone. This is Dr. Yuzo. This is ECE 360 and our 7th lecture. First of all, can you guys hear me? And also being able to see my shared screen with example 2 sketch on it. Okay, thanks, John. Thanks. Okay. All right, so let's start. Today we will finalize the module 3, the block diagram representation and reduction. And with a couple of more examples, I will give you guys enough time to do the in-class exercise. So at the beginning of the lecture, I hope you guys have your algorithm up to 4 moving block algorithm, or say the algebra, ready by side. Okay, because you guys gonna use that, apply those in example 2 and 3. Okay, as exercise. Okay, very, very important. Okay. So I'm presenting example 2 here. So take your time to copy the problem on your notes. And meantime, I just keep talking about the plan for today. Okay. So after finalizing the module 3, I'm gonna talk about one of the homework problem. And because the last lecture, I remember Sawyer asked one specific question, okay, about homework 1 problem 17b. So I'm presenting the solution here. It seems that the provided textbook answer is not right. Okay, so we will see how it goes. Okay. All right, that's all we're gonna do today. And if any time left, I will give you guys kind of opportunity to ask a question regarding the upcoming midterm. Okay. All right. So let's continue here. This is example 2, and we are seeing, well, is a quite complex interconnection among bunch of transfer functions. G1, G2, G3 representing a forward path from input R to output C, right? On both sides of the forward path, you have feedback, H1 through H4. Okay. Of course, you got to be careful, okay, to identify, correctly identify, are they feedback or feed forward, which is parallel, okay, sometimes. Okay. So be very careful. And also try not to memorize the transfer function names. What I'm saying is here is you can easily tell G1 through G3 are along the forward path. They are named by G, right? And H1 through H4 are named by H. Give you kind of impression that anything with name of H means feedback. No, that's not right. Okay, that's not right. Okay, don't try to memorize such kind of trick. This is not the valid, not always valid. Okay, so don't try to memorize in such way. Okay, don't try to remember the name of the transfer function of the block. It doesn't matter what's the name. Okay, what matters is the connection, is the algorithm. Okay. All right, take a look at this example 2. So first of all, what do we do? First step, what do we do? Never forget, at the beginning, always try to see or try to find somewhat available basic ones. Okay. What does it mean by basic ones? Cascade, parallel, or feedback, right? Is there anything like that in this example? We can really combine at the first place before anything else. Is there anything like that here? You see any? Anyone can see basic ones here? Anyone? But just speak. Okay, that's much more efficient. Here, Wally is suggesting G2 and H2 for feedback. What do you guys think?
I think that pickoff point messes that one up.
Very good. Excellent. Kevin is right. Be very careful, okay? If you're saying G2 and the H2 are stack, you can't have a pickup point here. It's absolutely messing that up. Okay, very good point, Kevin. Good job. And then Alex suggests G2 to left of pickup point. Well, Alex pretty much proposing the second step. So the conclusion is, at first look, this system, this given block diagram doesn't contain any available, easy, basic ones. All right, it doesn't contain any. So we move on. Okay, we move on. We move on by start thinking of moving block. Once again, moving block one at a time to come up with combination of multiple pickup points or summing junctions, so that from there we can be easy, basic ones, right? And according to Alex proposal here, we can move G2, which is this guy, left of the pickup point. So basically, I think he's saying moving this G2 towards left from the output end to the input end over this pickup point. So G2 gonna stay here, right? G2 gonna stay here. By the way, you can't move G2 over one pickup point here and one summing junction here. So if you move G2 over to here, that doesn't work. Okay? That does not work. Okay? Be very careful. Okay, at a time, one block, and moving past one pickup point or summing junction at a time as well. Okay, be very careful. We can't move over more than one company. Okay, so you can do this.
Move over,
yeah, go ahead.
Move over the pickoff point, do all the algebra, and then move over the summing junction and do the algebra again?
Absolutely. That's considered as the two steps.
Okay.
That's absolutely fine. That's absolutely fine. Okay. At the time, I said you can't move over more than, okay? Yep, that's it. Those two steps, of course, you can do. Okay. So this is Alex's idea, because after moving G2 like this, you can combine these two pickup points, right? And after doing this combination of two pickup points, you can actually combine what? G2 and H2 as feedback. Very good. And also, guess what? H1 and H3. Does that make sense? So this is a good idea. This is a good idea. This is a good idea, right? And the Sawyer suggests to do another move. He said, move H1 left of summing junction. Which one? Where? Here. H1. Move it left over this summing junction. Put H1 to here. If I understand him correctly, and then, well, it's not as effective as previous suggestion, isn't it? Because after moving H1 here, you got a unity feedback here. Well, you're not combining anything yet, right? Right. So moving H1 from here over this guy to here, or if I understand him correctly this way, then no, it's not very clear. It's not leading to a immediate convenience, I would say. Yeah, I think it's not a clear good move from here. So, any other suggestions? Any other suggestions we can do? Keep thinking. Some move works immediately. Some moves not quite. Any other suggestions for moving?
If you move G3 to the right of that pickoff point, H2 and H4 would be parallel then, correct?
move G3, right? We move G3
To the right.
to the right. Oh, to here?
Yeah.
And then you can do combination of these two peacock points. Yeah, that works. In my opinion, that works. That works. That works. That works. Good. That sounds a good plan at first step, because again, you move after this moving, you combining these two peacock points. Good. Okay. Generally speaking, is a good idea. Okay. Any other suggestion? Keep thinking. No rush to do it. Okay. In the exam, you need to rush. However, in exercise, you do no rush. Okay. Any other idea of moving? All right. Let's see my moving. Okay. My moving, well, is not necessarily better than Alex and Kevin's idea. However, just a different. My move is move G3 as well. However, move from the output end to the input end of this pickup point. We're pretty close to the idea from Kevin's. However, I'll move this guy to here to combine with G2 as a cascade. And then, of course, also combine these two pickup points. This is my idea. So let's do this move together. Well, either way should work. However, to kind of provide a solution, I need to go along with one single idea. So let's just move G3 from pretty much output to input of peacock point number 1. I can name this guy as number 1. Right. So once again, I'm proposing moving this guy from here to here. And then you can imagine the G2 and G3 cascade also peacock point 1 and the peacock point 2 combined. By 2, I mean this one. Does it make sense? After doing that, well, we can
Can't we parallel H2 and H4 as well?
You can parallel, let's see, H2 and H4 as well. Yes. H2 and H4. But be very careful. You need to do this step by step. Do you know what you need to be very careful? You can't directly come up with H2 plus H4. Can anyone see why is that? After this moving, the red color moving, you can see H2 and H4 are paralleled. No problem for that. However, you can't come up with a combination like H2 plus H4 directly. Can anyone tell why? This is something you need to be very careful. Can anyone tell why? No one? It's actually because of the algorithm. Think about this, okay, everybody, not only Kevin. After moving G3 from here to here, according to the algorithm, what do you need to do? The other output of peacock point 1 need to do what? Divided by the moved block, which is G3. Therefore, what? H2 is not H2 anymore, but H2 over G3. Same thing happened on H3, of course. But here, H2 is not H2 anymore. So if you directly come up with H2 plus H4, it's wrong, right? Because it's supposed to be H2 over H over G3 plus H4. Does it make sense? So be very, very careful. Okay, this is very easy to make mistake because you're skipping a step. Well, it's kind of like that. Okay, in your head, you might skip one step. Okay, that's why you need to be very careful. Okay, H2 and H4 two branches become parallel, no problem. However, when you write the transfer function, you need to be very careful because H2 is not H2 anymore. Does it make sense? Okay. So this is, as I said, H3 gonna be affected as well because once again, H3 is another output of the peak point 1. Okay, peak point 1. G1 remains same. And then G2, G3 combined, no problem. This is exactly what we are doing here. See, peak point 1, the two combined. Okay. The other outputs, the peak point 1 is one here, one go up, one go down. So affecting the H2. You need to divide by G3. Okay, this is a very important. Same thing to H3. Divide by G3 as well. Okay. Be very careful. Because once again, you move the G3 over peak point number 1. That's why. Okay. This is the result. Take a look. Take a look at this. Is one step moving, and then resulted block diagram. Take a look. See any questions?
Couldn't we use the parallel combination now, right? Because they're
From from here.
H3 and H4.
Parallel combination between
H2, G3, and H4.
Correct, of course. Yeah. In the exam now you can see it. These two now do. Feel free to do a what sum, right? To do a sum. Correct. And now is right. However, in the exam, be very careful. My point is, be careful. It's not H2 plus H4 if you do the parallel, but H2 over G3 plus 4. Okay, that's my point. If you're not doing enough exercise, this is very easy. This is a very easy mistake to be made. Okay, it's a very easy mistake to be made. Any questions regarding this this step? Of course, the feedback, all of the feedback, the sign remain. Okay, the signs, all of the signs remain. Okay, remain. And negative as negative, positive as positive. Okay. All right. If this is clear, then obviously, as said, these two parallel. These two parallel. These two parallel. Right. And you can combine them. And after this combine, you obviously need to do further moving, right? Further moving. Yes, you need to once again start to move. Then what do you want to do? What move to do? Any proposal?
So I'm thinking either we can move G2, G3 to the pickoff point before it, or G2 times G3 to the pickoff point before it, or I don't know if playing with G1, moving it to R, and then combining those two summing junctions, if that would be a better route.
Actually, both ideas I agree. I mean, I agree with both ideas. Okay. Both sounds reasonable. One idea John proposed is moving G2 and G3 over this guy, which means from output end to the input end, over this guy to here. So that you can combine this peak point with this peak-off point. No problem. Right? Or he said, well, how about we move G1 over this summing junction to here, so that I'm able to combine this one and this one. But that works too, actually. That works too. Okay. Any questions regarding the ideas? Because if idea is clear, just follow one of them. Okay, just follow one of them. Follow the first idea from him, which is same as mine. So that's why I choose that. Okay. And how about move G2, G3? Of course, before that, you can combine what? H2 over G3 and H4 as parallel. Of course, you can do that. And then you do moving. Move G2, G3 from output to input of peak-off point 3. How about that? We define this as a 3. Then I give you guys kind of a couple of minutes to come up with the resultant block diagram yourself. Go ahead. From here, go ahead. Okay. 2 or 3 minutes, and then I will present the solution. Go ahead, do this move yourself with the 4 algorithm by side. Follow those algorithms to see what happened.
I kind of have a question on the negative symbol with the summing junctions.
Which summing junction?
Well, I guess in general, all of them. Like, let's say we're getting a transfer function. Like, how do you know that the negative symbol is just appearing? Shouldn't we know if that's going to be negative if it's coming from the transfer function, right?
No. Negative is the negative of the signal rather than the transfer function. In other words, negative is applied onto the output signal of the transfer function you're talking about. You understand what I'm saying? It's applied on to the signal rather than transfer function.
Okay.
Transfer function is transfer function, and then the output of it is a signal. So differentiate the signal and the transfer function. Okay, these are two different things. Negative sign can only be given to a signal, not transfer function. You can't change the transfer function.
But the transfer function that you derive, you cannot. Like, let's say the transfer function itself is negative, but you're doing negative feedback. Those two wouldn't cancel, correct?
Your transfer function is negative. Well, to be honest, I almost never seen that happen before. But it can, because your transfer function, your output equals to the transfer function. It's like this, right? your outputs, for example, this is H, your output here is equals to input times transfer function. And if you go to, you give a negative on the output, the negative output equals to what? I mean, the negative here is like a give operator right in front of the signal output here.
Okay, so then if H transfer function, like let's
Is
say you have-
negative by itself.
yeah, like is that what determines why the summing junction, like why we're putting minuses there?
No. Again, this summing junction is trying to apply a operation on the signal here. Your transfer function H is positive or negative. We don't care.
But somehow the summing junction is negative for that portion.
So
I guess I just don't know, how do you determine that your summing junction when you're putting your transfer function together is going to be negative? Like what I would have thought is like wouldn't all the summing
no,
junctions
for example, you're saying, for example, if these two are parallel, or for this two are parallel, you're asking this, right? It's something like this. How to combine these two?
Yeah, I get how to combine those two, but
with negative for both, the negative H2, G3 is basically, first of all, since these two are parallel, so their relationship is H2 over G3 plus H4, right?
yeah.
And since you have a negative here, you give a negative here, and then negative here, you give a negative here.
But we factor that out and we just put a negative at the summing junction, right? So we can just write H2G3 plus H4.
Yeah, you're
So
talking about
negative
in this way, right?
going into the summing junction, correct?
Yes, then this one go to the summing junction, yeah.
And now, see,
Or you like it, you give a summing junction as a plus, and then you need to have here negative and here negative. Same way.
Yeah, but I guess I'll probably know more the more I work with them.
Okay. All right, let's see the solution for this step, okay, for this moving. Then what is the result block diagram? Hopefully the Q&A between me and John didn't bother, didn't distract you guys from deriving the solution here, but here is the answer, okay, here is the solution. Obviously, G1 remains. So G2, G3 over peak out point 3 to here, and then this summing junction is nothing but this guy. And then you have G2, G3 here, right? This is the summing junction combined, which is nothing but 1, 2, and a 3. That makes sense. The top one, H3 over G3 remains. It's not affected. This is C, right? However, you passed over a peak out point. According to the algorithm is what? From output to input, what you need to do? The other output of the peak out point, which is here, H1, need to do what? Divided by, right? Divided by. H1 divided by what? G2 times G3, right? Because you're moving G2 times G3, right? And what matter is this end is going to where? Just here. Does that make sense? Because you just combine this node is nothing but the pickup point 3, and you're doing combination with the 1 and 2. So it's end up here. End up with here, right? And meantime here is what? You keep here as we just mentioned, and it equals to this. Then keep take a look at this. See, does it make sense to you? The same as yours, or say? Okay. So this is pretty much the original pickup point 3. You move this guy over here, and then this pickup point, you drag it, kind of drag it flat, and then just intersect with here, this particular point. Does it make sense? Any questions regarding this move? Any thought? Any questions? All right, if this is clear, then what do you guys think? What do we have now? Once again, after every single move, you want to immediately think of any available basic ones, right? Before conducting the next move, right? So feedback, which feedback?
G2, G3, and the H2.
Yeah, this is one feedback. This is one feedback, no problem. Now this feedback, no problem. Anything else?
Parallel, the H3, G3, and H1, G2, G3 at the top.
Good. These two parallel. Very good.
And can't we also do the unity at the very bottom?
Excellent, excellent. So this is parallel, actually including 3 branches, right? Also, the bottom down here, does it make sense? 1, 2, 3, unity. 3 are parallel. Does this make sense? A little bit tricky. If you didn't notice that, I don't believe it's gonna affect your final correct answer. However, if you find it, they save some time actually. Okay, it's a good point. 1, 2, 3, 3 are parallel. No problem. That doesn't make sense. Because it doesn't matter where you sketch them. Over the top of the main path, or beneath it. It doesn't matter. Engineers do not matter the look. I mean, it's not our number 1 priority. Right? Good, very good. Okay, so we can do this. So 3 branches start out, and also 1 feedback. Right. And then the result. And the resulted block diagram gonna becomes this time it's gonna be quite easy. Now quite easy. Of course, when you do the parallel combination, be very careful about the negative or positive sign at the summing junction. Okay, be very careful. Be very careful. All right. Main pass, main forward pass, 2 summing junctions. The second one is gone because of the feedback, right? This feedback is what? You guys just go ahead, write this answer. And what is the, obviously, does it make sense? This is a resulted block diagram after you combining 3 parallel and 1 feedback. So what matter is just what we have here and what we have here. Go ahead, give you guys for 3 minutes and see what you got. All right, let's see the answer here. So to this feedback here, this is obviously the result of the feedback. So numerator is what? What is numerator? G2, G3, right? And what is the denominator? 1 plus G2, G3 times H2 over G3 plus H4. Right? This is the feedback transfer function. Okay. Combine this two. Right? And the parallel is fairly easy. Just H3 over G3 plus H1 over G2, G3. And don't forget 1, unity. Okay, don't forget unity. Does it make sense? Any questions? Anything? Everything makes sense? All right, if this is fine, then What do you see? You see, obviously, these two are what?
Cascade.
Cascade. Yep. After a cascade, you get another feedback, and then done. Once you reach here, of course, nothing on your way. Nothing on your way. Nothing on your way. It's just to do the last. So one cascade followed by one feedback, done. Okay. One cascade followed by one feedback, and done. So the results are right. This is the result, and this is kind of the result also presented in the exam. Okay, just one big block containing one single transfer function with one input and one output. That's it. This is the answer. This is the answer. So there's a feedback, right? So the numerator is what? Is the forward pass transfer function, which is G1, G2, G3 in here, 1 plus G2, G3, parentheses, H2, G3 plus H4. Denominator is 1 plus. Oh my gosh, this is quite a bit right. This is H what? H1.
You said that we should not simplify any like terms, even if we can, right?
Yes. Well, even if you can, of course you can. You definitely can. I believe you can. However, you don't want to do that. What we don't need to do that. Okay. Set kind of result to see. I can easily tell it's right or wrong. Actually, and it's done. Alex, for reminding. I've been looking. What is the missing subscript? Anyways, is H1 correct? Yep, he is right. Okay, remember, this is the good result. This is a good result. Okay. If you do organization on it, well, first of all, you're wasting your own time during the exam. Second, well, I can't give you a cross directly, of course, but I need to spend more time as well to figure out the correctness of your answer. Okay, so this is the perfect answer. Okay, this is a perfect answer. All right, any questions? Take a look. Let's see any questions here. Well, since you very likely to have different ways to move the blocks, not only the step, every single step of moving might be different from one student to another. So how I greet you guys is not watching the final answer. Okay, I never do that as grading. Okay? I follow your idea to do the moving myself to see if your moving is right or wrong. So I would highly appreciate, listen carefully, I would highly appreciate if you tell me what you are doing, like I'm writing here. I'm moving G3, okay, from output to input side of peak off point 1, which I also labeled in the given diagram. That's gonna be highly appreciated. Okay, that's of course also the best way for the students to claim any partial credit. Okay, so if you want to provide more answer, do something like these. Okay, rather than organizing the final answer.
Do we get extra credit for it?
Extra credits? No. We're talking about partial credits, not extra credits for it. Well, the thing is, if you're not putting these things, I cannot say you're wrong. I cannot. I just spend a little bit more time to figure out what you did. Okay, so it's kind of help me understanding you better. Okay. So I appreciate that. However, no extra credit. Okay, no extra credit for this. Okay, this is just too easy. This is too easy. This is too easy. If you're moving and every result is right, you definitely know what you're doing. So it's not extra work. It's not extra work from your brain, right? From your engineering skill, not extra. You're not presenting any extra. Any other questions? Any other questions we can discuss? All right, if nothing, then go ahead. Example 3. Example 3. Let me see what example 3 is. Okay, here. Unfortunately, once again, multiple peak-out point and summing junction. Okay. Yeah, such kind of look is a little bit scary, but it can be always solved by following the basic principles we learned. Okay, so don't worry too much. No, miss one. I missed one feedback here. All right. Now start running your brain. How to organize this one? What do you see first? Anything you can see? By anything, I mean any basic ones you can see, right? I think you guys still copying the problem, so keep doing it.
Is there feedback with that middle S?
Middle S and whom?
The one going back to the
Good.
summing junction.
Obviously, this one is a feedback. No problem. We're gonna do it, and we're gonna do this. This is absolutely feedback. No problem.
Don't we have another feedback on the 1 over S plus 1? With the
On this side,
of it,
with whom?
the unity above it.
Very good. Second feedback. Good. Anything else you can see? Anyone see anything else? A little bit tricky, but it's actually it's there. Very good. We are seeing two basic feedback, very accurate. No problem. I can write it up. But there's something else you can do as well.
A parallel on the S and the 2S.
Parallel between S and 2S. Can you do that? Kevin said this two parallel. Can you do it? Anyone? Can you do this parallel? Anyone?
Aren't they different points? Like they land at
Different
different spots.
But actually, these two cannot be parallel. The reason is this peak-off point here. This peak point is right in the middle along this second path. It's going out. This peak-off point messed up this. Parallel.
Is there a feedback going with between the 1 over S plus 1 and the 4 at the bottom? Like,
Oh, very good. I think Wally got a very good point. Actually, Wally say this guy is a parallel. Is it feedback with 4? Is it? Can you guys tell that? It's a little bit hard to tell. And his answer is not very accurate. But actually, what you can do is what? First of all, 1 over S plus 1, if you see the top unity negative feedback here, you can do this combination is good enough already. However, Wally's point is actually should be interpreted in this way. Look at this summing junction. What can you do about them?
Add them
You can
together.
combine, right? You can combine this two junction. It's a little bit tricky. However, you absolutely can. Why not? You can combine two summing junction. There's nothing in the middle, isn't it? You absolutely can do combination. Okay. After combination, you see what? 4 gonna be a negative feedback. And from there, you can see what Wally just mentioned. Okay. But before that, do the combination between these two. Does it make sense, guys? Yeah, it's a little bit tricky. However, we name this guy as 1, this guy as 2, and you can do this 3. You can do these 3. If this makes sense, of course, it's also including why we cannot do parallel between these two. Okay, this is also very critical understanding. Because of this peak-off point out of in the middle, you gotta bothered by this peak-off point. Can do it. Okay. So if every details we just discussed are clear, go ahead to conduct these 3. Conduct these 3 okay. Yourself. Give you guys kind of 3 to 4 minutes. Go ahead. I'm sorry because I didn't say anything. Okay, that's why you can't hear anything. I'm just sketching, presenting a solution. I'm not talking yet. Okay, I want to give you guys a little bit more time to sketch the block diagram. So here is the solution here. Two feedback. The result of two feedbacks are here. Okay? The forward transfer function is S. Feedback is unity. So S over 1 plus S is the result of this feedback. This feedback, the forward transfer function is 1 over S plus 1. And divided by 1 plus what? 1 over plus S plus 1, right? So end up with 1 over S plus 2, actually. Okay? I did a little bit of organization here. That's why it looks probably not super clear. And here's the key, right? Here's the key. How to combine these two summing junction. So first of all, in your mind, you keep in mind what are the signals you're combining, okay? Signals. So first of all, this is one signal. Positive of this signal goes through this summing junction 1 and then enter into summing junction 2 with positive again. So the total is positive. Does it make sense? Which is this signal. Once again, positive, positive, remain as positive, go into here. Right? Another signal going into the summing junction 1 is this signal down here, output of the 4. Be very careful now. First, this signal goes through this negative and then plus into summing junction 2. So this signal output of the 4 should be positive or negative here. This signal goes into summing junction 1 as negative sign in front of it, and then combined with summing junction 2 was positive. So what is it? Is positive or negative? Negative, correct. Okay. It's like you have a number, whatever number is, you give a negative of it. For example, your number signal is 1. Here becomes negative 1. Negative 1 plus negative 1 means positive negative 1, which is negative 1, right? So here we go. You see, this is a resulted block diagram after step 1. Take a look. See any questions you have?
I got a quick question.
Mm-hmm.
That 2S to the right side of that pickup point is still 2S, correct?
2S. You mean this one?
Yeah, but below on your new chart down there, below the S over 1 plus S, is that still 2S? Right
Here?
there, that line? Yeah.
Oh, no. Once again, this is a signal. This is not a transfer function. When you talk about a 2S is a transfer function, not a signal. This is the signal.
Okay. So that's just a 1.
Yes, so this signal is here. Original is here. Okay,
Right.
This is the signal. And what is this signal is? Well, it's really hard to tell. Right? We don't know, actually. So but here, the transfer function remains same here. And this signal is this signal. This is the answer. Okay, this signal is this signal. This signal is this signal. Okay, the composition of a block diagram have transfer functions, summing junctions, pickout points, and the signals. Remember, so differentiate the signals and the transfer function. They are not the same thing. They're not the same thing. And algorithm, the moving block algorithm, is in terms of what? Not signal, but transfer function. This is a little bit tricky, but in your mind, these concepts need to be very clear. Okay? Algorithm is talking about how to modify the after moving transfer function of the block, right? It's not talking about a signal. Is this result clear? Any questions? And if this is clear, then what we need to do next? Of course, here we have a positive, positive. What we need to do next? Any idea? Any idea?
I got feedback for the 1 over s plus 2 and the 4.
This is feedback, no problem. This feedback, no problem. Anything else? The answer is no. No other clear basic ones. No others. Okay, no others. You can't do anything else. Obviously, we do this feedback combination. No problem. Besides, we need to start to move. Right? Start to move. What moving idea do you have? This is not difficult anymore. So, what moving idea? Any idea?
Could we move the s over 1 plus s to the left of summing junction 1?
Yep, I like that idea. I like that idea. I like that idea. Well, actually, this is summing junction 1 and 2. Are you meaning this one?
No, I meant the 3.
Yeah. Yes, so let's name this as 3. Yeah, I agree with it. We want to move this guy over number 3 to here to combine with S as cascade, right? Moving S1 plus S from output to input of sum junction number 3. Right. All right, give you guys 2 or 3 minutes to do this yourself. Or let's see the results diagram. What does it look like? Okay. This is a very, very important step. So once again, this guy move over here, and then you're gonna combine with obviously s. So here it becomes s squared over s plus 1. And then you're gonna combine summing junction 1, 2, 3 together. Right? Meantime, can't lose this 2s. And guess what? It's a little bit tricky. This is a result block diagram. You might have different look, but basically should be the answer. And let me explain a little bit what's going on here. So you move this block over summing junction from output end to input end, right? So according to that, what we should do? Other input of the summing junction need to what? Times the moved block transfer function, which is s over s plus 1. That's why you have this guy here. And then you combine number 3 and 1, 2 together. That's why it is over here. Does that make sense? The signal remain in this signal. This signal go into the summing junction. This signal remaining go into the summing junction. Just that in the past, you have an extra transfer function due to the algorithm. And this unit path remains. You can't lose it. Does that make sense? And this is the result of the back up here. Here, Noah is asking, so why isn't S multiplied by the moved block before being cascaded with it? What do you mean by that? Why isn't S multiplied by the moved block before? Well, after moving, this guy combined with this. That's why you have a square here. After moving, you do something in the past as the other inputs of this past summing junction. Here, you're adding a transfer function here. This is the input. This is the moved end. You're moving from the output to this end. So you're not doing anything. The other, remember the algorithm, the other input of the summing junction, which is here. You have two inputs. Input is the one you're going to move. The other need to times a moved transfer function like this. Yep, the algorithm saying other inputs, which is this guy itself. Okay. Yep, that's the trouble of typing. This communication is very low efficient if you are typing. At the No. I'm not doing adding. This is the feedback. Yeah, these two are feedback. I'm not adding. You add 4 onto the denominator. No, I can't do that. There's no principle or any reason for doing that. It's a feedback. You follow the feedback formula. You end up with this. Okay. You can't put your 4 into the denominator. Why is that? What's the basic principle? You can't do that. Never. Any other questions? All right, if this is fine, then what do we see here? Now what do we see? What can we see? Here, Kevin is suggesting step 3. Parallel the S over S plus 1 with unity. Good. So he's saying here, these two are what? Parallel. No problem. And then cascade with 2S. Very good. This is a cascade. Very good. And then parallel with S squared over S plus 1. Very good. This is a parallel. Basically following him to reach this step, and then you only have, what, 2 blocks left with 1 unity feedback. Right? And then from there, you do the moving or not. It doesn't matter anymore, right? Doesn't matter anymore. But let's summarize Kevin's idea. So S plus 1 and the unity are parallel. Then cascade with 2S. Then to what? Parallel again with S squared over S plus 1. Right? If you see this, then it's basically done. Basically done. These two plus times 2S. Right? And then this thing parallel with S squared over S plus 1. Right? Then cascade with 1 over S plus 6. With unit feedback on top, it doesn't matter. Does it make sense? This is the result. This is the result. 1 cascade, 1 parallel, 1 cascade, another cascade. Done. I think this is very difficult. And then the last one, just do what? Just do 1 cascade, these 2 cascade, and 1 feedback, and then the total gonna be like this, right? Total gonna be S. Right? 1 plus same thing. Does it make sense? Any questions? This is the answer. They're organized. Right? Well, good. Thank you, Noah. Good. So this is pretty much the end of the this module. And of course, next on Monday will be the exam, and we follow the lecture time for exam 1 to 2:45. And I have my office hour right after this lecture, so I'm gonna just continue from this and if you have something else to do, please feel free to leave. Otherwise, I'm gonna present the solution, or say the correct solution for our homework 1, number 17b. Okay, and Sawyer lost the lecture ask for it, and I looked into it and found, well, it seems the textbook solution is not right. It's not quite right. Okay. Anyways, let's go over this problem. The problem is fairly easy. You have a 2 meshes circuit with input given labeled here, and outputs you're looking for, or say the output you defined, is the voltage across this capacitor, 2 farads, and looking for the transfer function between output and input. Everything very clear. So what do you do to such problem? First, always conduct a Laplace transform. Vi of t becomes capital Vi of s. V naught of t becomes capital V naught of s, right? And the most important thing is the impedances. Okay, resistor is easy, remain same. How about the inductor and the capacitor? Inductor's impedance is what? Ls. L is 1, then end up with S. The impedance of the capacitor is what? 1 over Cs. C is 2, okay, 1 over 2S. This is the frequency domain circuit. And, no matter what, this circuit must be done correctly, based on which we further to derive what's the output voltage here. Right? How to do this problem? You have obviously more than one way to do it. Maybe 2 meshes, I don't mind. It doesn't matter, it's okay. However, my way to do it was what? Can anyone see what I'm doing here? Very good. Okay, you gotta recognize it. It's nothing but voltage divider. Okay, it's nothing but voltage divider. Okay, nothing but voltage divider. Okay, 2 times. Okay, I apply voltage divider twice. Okay, twice. So first, I'm in this circuit. I'm looking for the voltage across here, whatever you call it, V maybe. This voltage across here is equals to what? A voltage divider, right? 1 ohm is sharing Vi with what? Parallel between these 2 branches. Because 1 ohm is series connected with these 2 parallel, right? So this is voltage divider 1. Second voltage divider is what? After you finding this V here in red, S and 1 over 2S is sharing this total voltage, right? This is obviously the second voltage divider for you to find the voltage across 1 over 2S. So 2 voltage dividers. I have 2 voltage dividers. So if this is clear, and then blah 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 blah, bunch of algebras, and this result.
Is this is 19A, correct? Not 18A, sorry. I see.
17B.
Oh, 7.
Are you still there?
Oh, okay. I see it. Sorry. I got you.
So this is the I think is the correct answer. The solution provided from the textbook. I'm afraid it has something wrong with it. But anyways, is there anyone here reach the same answer as I do here?
Yeah. This is also this answer is also on Slater, not on Chegg.
Check. Yeah, but don't follow those things. Okay, I'm not trying to. Yeah, this is this bring since you bring up this name, I want to talk about it a little bit. These websites are frameworks for providing solutions for homeworks as well as even the exams. What I'm saying is this: the cheating, of course, no matter what, is wrong. Don't provide any evidence or provide any opportunity for faculties to catch you. Okay, don't even think that. It's no good, no matter what. Second, more importantly, I think my classes are not giving any hard time. Okay, I'm trying to make my lectures, my materials, like learnable, for you to learn something, to worth your money paid, and therefore you will be able to do a decent or well enough in exams. Okay, my exams are closely related to what I have ever taught. Okay, it's not a hard time. What do you need to do? Just learn something, make it worth your money, and do your own good. Okay, and then in the exam, it's not that hard either. I mean, it's related. It's closely related. Why the H you would like to cheat? I always ask or say I always have such kind of question. I'm not finding any question, any reason for my student to cheat in my exams. Okay. However, in case you have some reason which I can never understand, don't do it. Okay, no matter what. Okay? Don't follow those websites. Okay. So try to learn the material, and the same thing on the exam and the homeworks too. Completing the homeworks, useless, except you can learn something out of it. All right. So some students still thinking of the that deadline or that time, the due time of the homework. You don't need to worry about it. As long as you can learn something out of it, you turn in the homework or not, it doesn't matter. All right. Okay, come back to here. Any questions regarding this problem? Any more questions?
So if that was for 17B, 17A, what was the solution?
17A.
Yeah.
17A, I didn't receive questions about it, so I didn't look into it. But the solution is say 17A. Oh, by the way, the solution has been posted online. Okay, it's been posted in the Canvas. Is equals to 1 over s plus 2. 17A's answer.
Okay.
Any questions? Do I need to look into it?
I mean, I didn't get that, but I can always go over it again.
Sure. If you just
17A was the original one.
okay.
That's in the book is different than what I saw online.
Okay. So did you got the same answer as I do in 17B, Sawyer?
Yes.
All right. Then you're good. You're good. And also in the exam, remember, okay, assign your time on here, majority of your time, okay, on here, and here. If you do have extra time, plenty of extra time, go here, and here. Because they are not waiting a lot of points. They're not. your logic, your skills, your capability are presented, are shown here. Not here. Okay, not here. Any other questions? Well, I think I should turn off the recording here. And if any more questions, once again, it's my office hour. Okay. So thank you for attending today's lecture, and talk to you guys later. Bye now.